Good morning, everybody. It is Tuesday morning after Labor Day. Hopefully you guys had a really nice long vacation, sleeping in. It was nice. So I went to Bend and had a great time. So anyway, back to math. So today what we want to do is talk about this. If we have two lines, okay, two lines specifically, here are two lines, where do they intersect? And where they intersect is actually the solution. So I got two lines here. I'm going to graph them both and find out where they intersect. So what's our objective is solving 2 by 2 systems of equations. 9/8/2020, right? Okay, so first of all, we call them 2 by 2 because you've got two variables and two equations. 2 by 2, you have two variables, x and y, and two equations, right? They're called 2 by 2. So to graph this, we have to remember y equals mx plus b, slope. So equation 1, we're going to start at 5. 1, 2, 3, 4, 5 on the y-intercept. Has a slope of 2 over 1. I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, okay, so forth and so on. Connect the dots. Boom, there you go, okay? So hopefully today is a nice review for everybody. You should be able to do this. Equation 2, okay, there's equation 1. Equation 2, start at -1 for a y-intercept. Let's see, I'll use a different color for that one. Why not? I'll just use a different color. I can do a different color. Do I have a different color? Well, okay, here we go. I do have a different color. Okay, there you go. You put this one in blue. Start at -1. And then I'll go, remember, 1 over 1. I'll go up 1 over 1, up 1 over 1. So what I'm really looking for is the point of intersection, because that's my solution. So the graph is not the answer. The answer is the point of intersection. So my answer is the point of intersection. And in this case, the point of intersection is at the point 2, 1. Okay, easy. Should be a nice review of something you learned in geometry and also stuff you learned in Algebra 1, okay? Now, example 2. Example 2 is going to take a little bit of work, okay? So we've got equation 1. We'll have a 2x minus 3y equals 3. Equation 2, x plus 2y equals 5. So to graph them, what I want to do is solve for y. Okay, so I'm going to solve for y so that it looks like the first one, so I can get a y-intercept and a slope. Okay, so I'm going to solve for y. So to get rid of the 2x, I'm going to go minus 2x minus 2x. Okay, we did this last year. A -3y equals a -2x plus 3. Divide by -3 all the way through. Divide by -3. Divide by -3. Divide by -3. I get a y equals a 2/3 x minus 1. Okay, start there at -1, right? You can pause this if I get going anytime. Pause it to catch up. Up 2 over 3, up 1, 2 over 1, 2, 3, up 2, 1, 2, over 1, 2, 3. Okay. All right, let me graph that line in. There you go. There's line 1. Okay, line 2, let's do the same thing. Solve for y. We'll go minus x. To get x by itself, minus x. So that'll be gone. We'll have a 2y equals a -x plus 5. Divide by 2, divide by 2, divide by 2. I get a y equals, now there's a 1 here, invisible 1, right? Invisible 1 there. I get a -1/2 x plus 2.5 or 2.5. So now that's kind of harder to do, but we can do it. I have faith in us, so we'll start at 2.5. 1, 2.5 is right about there. Now I'm going to go down 1. That puts me there. Down 1 puts me there in the middle. Down 1 and then over 2. Hey, how are you doing, Jonathan? I'm recording, but come on in, okay? Over 1, 2. Down 1, over 1, 2. It'll be a little while, okay? But go ahead and sit down and relax. Okay, now you're on camera. Okay, so then I get my point of intersection. That's a little bit unsure where it is, but I think it's right about there, okay? So the problem with this is our answer, I think, is 3, 1. It might be off by a little bit, so this is a little bit inaccurate. So one of the things we can do is learn how to solve these by algebra, okay? Generally, I'll be like 10 more minutes, okay? So then, I'm going to turn the page and take a look at how do you do it without graphing. Because graphing is kind of a pain. It takes a lot of work. And then it's also a little bit inaccurate. So is there a better way? Yes, there's a lot better way. So the better way is to do it by algebra, okay? So, example 3, solve by elimination. Okay, what does elimination mean? Well, what elimination means is simply to eliminate one of the two variables. In this case, let's say a positive y and a negative y, okay? If I were to simply add them together, then my y's, positive y, negative y, would cancel out. We did this last year. So I just recognized how easy this was. So if I add them, I'm going to get a 2x plus 3x. 2x plus 1x makes a 3x. Positive y, negative y cancels, equals a 5 plus 1 is 6. Okay, now that gets pretty easy, doesn't it? Divide by 3, divide by 3. Okay. Cancels, and I get x equals 2. Now remember, it's a point. So my answer is 2 something. So I've got the 2. It's a point. But I don't have its y value. So I'm going to take my 2 and plug it in to either, it doesn't matter, either equation 1 or equation 2. I'll just take it and plug it into equation 1. So if x is 2, I'll plug the x right into there. So let me rewrite this equation. So equation 1, 2x plus y equals 5. I'm going to plug my 2 right there. So I'm going to go 2 times 2 plus y equals 5. I will have 2 times 2 is 4 plus y equals 5 minus 4 y equals 1. Okay, now there's my answer. So my answer is 2, 1. I never graphed that line. But if I did graph it, they would intersect at the point 2, 1. And that's what I really want. So go back to this. What I really want is the point of intersection. Okay? So I got the point of intersection by using elimination method. Now, example 4. Okay, to solve the system by elimination, okay? So what I would do on this one is, well, they don't eliminate. But what I can do is I can multiply first. I can multiply first. Okay? So if I multiply first, then what I can do is this. Well, if I multiply this second equation by negative 2, why would I do that? What the heck? What are you talking about, Mr. Davies? Why would you multiply that by negative 2? Well, hold on. If I make that a negative 2x, then these will cancel. Ah, I get it. So 2x, and that becomes a negative 2x, and then they'll cancel. Now, if I multiply by negative 2, let's rewrite these two equations. So I still have the top equation, equation 1. I'm going to keep as 2x minus 3y equals 3. But equation 2 I'm going to change. I'm going to multiply through to everything. Multiply through to everything. Multiply through everything. Equation 2 now becomes a negative 2x, a minus 4y equals a negative 10. Okay, now if I were to add and use the elimination method, then what happens is a will cancel. That with that cancels. I'll get a negative 7x equals a negative 7. Oh, I like this. It's going to work nicely for me. Divide by negative 7, divide by negative 7, x equals 1. Now, that's only half the answer. So my answer is 1 something. So I'm going to take my 1, which is x, and I'm going to plug it into either equation. So I can go all the way to the top. I think I'll take it and plug it into the second equation, the original second equation, because that just looks like the easiest equation to put it into. So I'll put 1 right in there for x. So remember, I've got an x plus a 2y equals 5. It's my original equation 1. That's the easiest one to put 1 right in here. So instead of writing x, I'll write 1 plus 2y equals 5, and I'll solve. Minus 1, minus 1, I've got a 2y equals 4, divide by 2, y equals 2. So my answer is 1, 2. Okay, now, let me show you a couple other little things, okay? So your homework today is going to be this, and it's on a link, so when you open it up, you got to see it's a link. But I want to show you a couple of things. So first of all, if you take a look at like number 10, you can multiply through by -2 and eliminate. But number 11, you could subtract and you can cancel out. But there's some problems where you do things by what we call the substitution. So I want to show you real quickly on 11, what I would do on 11. On 11, since they both equal y equals 1/2 x, y equals -1/2 x. Since this equals y and this equals y, then they equal each other. So on 11, I would simply start off with a 1/2 x plus 1 equals a -1/2 x plus 9. Okay, think about this. This first equation equals y, second equation equals y. They both equal y, therefore they equal each other. And I would just solve from there, okay? Get x and then substitute back for y, okay? Same thing on 14, I'd set them equal. Oh, here, I wanted to show 16. Now 16 is unique because we're going to do what we call a substitution. And we learned all of this last year. 16, I'm going to have y equals a -x plus 3. And then I'm going to have a 2x, oops, my bad, x plus 2y equals 0. By substitution, since y is equal to a -x plus 3, I'm going to plug that in for y. So I'm going to substitute. Since y is solved for, instead of writing y right here, then I'll write x plus 2, but not y, but what y is equal to, a -x plus 3 equals 0. X equals a -2x minus 6. That's a minus equals 0, and I'll have a -1x minus 6 equals 0, and you can solve for there. Okay, anyway, this is your assignment. It is attached to the homework. It's 1 through 18 all, and number 19 is the extra, okay? If you have any questions, just ask. I can help you out. But we did this last year. It's not in the book. They skipped it, but I think we need to go back through it. Okay? All right. Good luck. Open up the assignment. There's a link. Click on the link, and this should pop up.